Good morning to all. I am Dr. Ganesh, Assistant Professor, Department of Aeronautical Engineering, Hindustan College of Engineering and Technology. In this video, we will discuss about Introduction to Solid Mechanics. The outline of this video is as follows: stress, strain, types of stress, types of strain, Hooke's law, elastic constants, and Poisson ratio. First, we will see stress. Stress is defined as force of resistance per unit area offered by a body against deformation. When an external force acting on a body over a cross section, the stress will produce. The stress is given by sigma is equal to P by A, where sigma is the stress, the unit of the stress is Pascal or Newton per meter square, and where P is the external force or load, the unit is Newton, and A is the cross-section area of the body, and the unit is meter square. Next we'll see strain. Strain is defined as ratio of the change in dimension to original dimension of an object under application of external force is strain. When you are applying a tensile load on your body, so if the L is the length of the original length of the body and it will extend it to del L, that elongation is given as del L, where strain will be given as epsilon is equal to del L by L, where epsilon is the strain and del L is the change in dimension and L is the original dimension. The next is types of stresses. So only two basic stresses are exist. First one is normal stress sigma and second one is shear stress tau. The other stresses either are similar to these basic stresses or a combination of these. Example, bending stress is a combination of tensile, compressive and shear stress, and torsional stress as encountered in twisting of a shaft is a shearing stress. So now we'll see the normal stress. Normal stress is also called as linear stress or direct stress. If the stresses are normal to the areas considered, then these are termed as normal stress. And based on the direction of the normal stress, again the normal stress is classified as tensile stress and compressive stress. And based on the number of normal stresses acting on the body, the stresses are classified as uniaxial stress. If one normal stress is acting on your body, it's called as uniaxial stress, and if the two normal stresses acting on your body is called as biaxial stress, and if three normal stresses are acting on your body, it's called as triaxial stress. And next type of stress is shear stress, where the cross-section area of the block of material is subjected to a distribution of forces which are parallel or rather than normal to the area concerned. Such forces are associated with a shearing of the material and are referred to as shear forces. So here we can have the body, so where the forces are acting parallel to the area concerned, where the shear stress is given by tau is equal to P by A, where tau is the shear stress and P is the total force and A is the area over which it acts. Similar to stress, the strain types of strain is classified into normal strain and shear strain. Normal strain is also called as linear strain or longitudinal strain and is denoted by epsilon. Where when you are applying an axial load, tensile or compressive load or normal load acting on your body, the length of the body will extend. So this gives the normal strain. Similarly, when you are applying a shear force on your body, it will produce a shear strain. It will be denoted as gamma. Hooke's law, which relates the stress and strain. The stress is directly proportional to strain within elastic limit of the material. So which is given by sigma is directly proportional to epsilon. And this can be written as sigma is equal to E into epsilon, where E is the elastic constant, where E is equal to sigma by epsilon, where Sigma is the stress and epsilon is the strain, and E can be written as Young's modulus or proportional constant. And the unit for the Young's modulus is Pascal or Newton per meter square. The next one is elastic constant. So there are three types of elastic constants. The first one is Young's modulus or modulus of elasticity, which is denoted by capital E. And the second one is shear modulus or modulus of rigidity, denoted by capital G. And the third one is bulk modulus, which is denoted by K. First, we'll see about the Young's modulus. Young's modulus or modulus of elasticity, the ratio of the tensile or compressive stress to the tensile or compressive strain, where E is equal to sigma T by epsilon T or, or sigma C by epsilon C. And the second one is shear modulus or modulus of rigidity. The ratio of the shear stress to shear strain, which gives the shear modulus, where capital G is equal to tau by gamma, where tau is the shear stress and gamma is the shear strain. And the third one is bulk modulus, the ratio of direct or normal stress to volumetric strain. If three normal stresses are acting on your body, sigma 1, sigma 2 and sigma 3, the strain, the change in volume will occur on the body. So where K is equal to sigma by epsilon B, where epsilon B is the volumetric strain. Volumetric strain epsilon B can be given as the strain in x direction plus strain in y direction plus strain in z direction. So that we can written as epsilon x plus epsilon y plus epsilon z. The next important constant is Poisson ratio. The Poisson ratio is defined as the ratio of the lateral strain to linear strain or longitudinal strain, where Poisson ratio is generally denoted by mu is equal to lateral strain divided by linear strain or longitudinal strain. If you apply a tensile load or compressive load on your body, there will be a elongation in longitudinal direction and compression in lateral direction. The ratio between this lateral strain to the longitudinal strain gives the Poisson ratio. Thank you for watching this video.